Alright, this is our Chapter 8 study guide on factoring and multiplying polynomials. So here we go. The first one says we're going to find the degree of each monomial. So again, the degree means basically how many variables total does your problem have. So if we were to write this the long way, we would have 3 x's and we would have 4 y's. Therefore, this is called a 7th degree monomial. For number 2, same thing. If we were to write this the long way, we would have 12 x's and we would have 1 m. So therefore, this is called a 13th degree monomial. Pretty easy. Number 3, we are finding the sum or difference. So this is simplifying expressions. And when you're simplifying expressions, it's like you're making your grocery list and you're combining all the things that are the same into one. So we look here, the first thing I see is a 4ab. Or the first thing is I like to get rid of the parentheses, which you might say isn't really needed at this point, but you're going to see how it's helpful when we get down to number 4. So if we get rid of the parentheses, there's really a 1 in front of here. So that becomes 4ab plus 2h to the third minus 5h squared. On the second one, we have a 1 in front as well. So that becomes a 17ab plus 4h to the third minus 2a. So now we look and see if there's anything that can go together. So I see I've got a 4ab and I have a positive 17ab. So if we put those together, that gives me a 21ab. Then I look for anything else that's the same. I got some h to the thirds, so a positive 2h to the third, a positive 4h to the third. So that gives me a 6h to the third. And notice that we're only changing the coefficient, or that's the fancy name for the number in front, because we're changing how many we have, not what we have. We still have ABs, we still have h to the thirds, but we're changing how many we have because we're putting them in one group. Then we have a negative 5h squared, which there's no other h squareds, so we can't combine it with anything. So it stays negative 5h squared. And then we have a minus 2a, which we also can't combine with anything. And so we have our answer. Now from here, we're supposed to put this into standard form. So the 6h to the third should come first. Then see we have a tie here between 5h squared and 21ab. They're both second degrees. So here I don't mind which one you put first, but we would put the 5h squared first. But again, if you put the 21ab first, that's okay with me. And finally, we ended off with the minus 2a, because that's the first degree. So when you order them, the highest degree goes first, lowest degree goes last. Now, number 4 is when distributing the 1 is very helpful. Again, you might say, well, what's the point? There's just a positive 1 in front. So our first set of parentheses, nothing changes. It just stays 5w plus 3w squared minus 9. However, on the second one, there's a negative 1 in front. So all of those on the inside turn to their opposites. So we have a negative 7w squared. Negative times negative, we have a positive 2w. And negative times positive here, that gives us a negative 4. Now we can combine like terms. So I see some w squared, so I got a positive 3w squared and a negative 7w squared. So that gives me a negative 4w squared. Then I look, I got some w's, just regular ones, so 5w and a 2w. So that gives me a plus 7w. And then finally I've got a negative 9 and a negative 4, which make a negative 13. And I'm in the right order because I have a second degree, first degree, and then that's called a 0th degree. So distributing that negative 1 helps me realize that these are actually the opposite of these numbers in here. All right, number 5. Now we're on multiplication. Now when we multiply, we do change variable exponents. This is when the exponents do start to change. So multiplying, you can do the distributive property, or you can use the box. And I'm going to use the box because that's what a lot of students in the class are using. So r minus 8, I'm going to put that on top. R minus 5 over here on the bottom. So now to do the box, you just do the multiplication like you did in your science class, like with the Punnett square. So r times r is r squared. R and a negative 5 make a negative 5r. R and a negative 8 make a negative 8r. And a negative 8 times a negative 5 make a positive 40. So the multiplication has been done. Now we're going to combine like terms again. So we're going to make our grocery list into one and put the things together that are the same. So we don't have any r squareds, except for the first one, so we're just going to write r squared. But then we have this negative 5r and this negative 8r. Well, they can be combined to make negative 13r. Then we've got that 40 with nobody, so that just becomes a plus 40. And then that's our answer for number 5. So again, when you combine like terms, the variables don't change. That's the number in front. Okay, so number 6, same thing. I'm going to use a box. So negative 6y for r, 7y, negative 3r. So 7y, negative 6y make a negative 42y squared. We have a negative, let me try to get this a little bit better. We have a negative 3r and a negative 6y. That's going to make an 18ry. We have a 7y and a 4r. That's going to make a 28ry. And then a negative 3r and a 4r, which makes a negative 12r squared. Does not want to focus. So let me, sorry for the pause here. There we go. Okay, so now we combine like terms if possible. Well, there's nothing to go with that negative 42y squared, so that's going to stay the same. Then I see I have an 18ry and a 28ry, so those are the same. So an 18 and a 28 make a 46ry. That's a positive, so 46ry, because we combined these two terms together. And then we got a negative 12r squared. Can't do anything with it because we don't have any other ones, so we just write it down. And don't worry about order on this one. No, not a big deal. Now we go to number 7. So here again, I'm going to multiply, so I'm going to use that box. This time, though, I've got 3 terms in one of my parentheses. So that means I've got to have either an extra column or an extra row. So I just decided on putting an extra column. So that's going to be a 3x squared. That's going to be a negative 7x, and that's going to be a 4. And then I'm going to have a 2x cubed and a 5 off to the side. So now we just go through the multiplication process. 2 and 3 is 6. X cubed, x squared is x to the 5th. 2 and negative 7 is negative 14. X cubed and x is x to the 4th. 2 and 4 is 8 with your x cubed. Then we go down here. Now we're going to multiply everything by 5. So 5 and 3, that's a 15x squared. 5 and negative 7 is a negative 35x. 5 and 4 make a 20. So now we combine like terms. Nice thing on this one, there are no like terms. So we just have to write in the correct order. So highest degree first, so that's our x to the 5th. Then we have our x to the 4th. Then we have our x cubed. Then we have our 15x squared, our negative 35x, and our positive 20. So that was just one. That hardly ever happens where you don't have anything to combine, but it happened on that one. All right, number 8. We have 3d minus 9 squared. On this one, 3d minus 9 squared really means 3d minus 9 times 3d minus 9. So this time I'm not going to use the box. I'm going to use our shortcut that we talked about in class. And that's when you're squaring a binomial. The quick way to do it is you square the first term. So 3d times 3d is 9d squared. You square the last term. So a negative 9 times a negative 9 is a plus 81. And then to get the middle term here, you're going to multiply these two together. So 3d times a negative 9 is a negative 27d. Then you're going to double that number. So negative 27 doubled is negative 54. So it's negative 54d. And that trick only works when you're squaring a binomial. And we'll be doing more of that in the next chapter. All right, number 9, we have 2m plus 7, 2m minus 7. So again, I'll set the box up for this one. So 2m plus 7. Let's see if it focuses. There we go. And then 2m minus 7. So now we do the multiplication. 2m and 2m, 4m squared. 7 and 2m, 14m. 2m negative 7, negative 14m, 7 negative 7, negative 49. So now we combine like terms. 14m negative 14m, they cancel out each other because they're the opposites. So you're left with 4m squared minus 49. And some of you might have recognized that at the beginning because you see that this is the difference of squares factored form. So you know that the answer is just the squared with a minus sign. But if you didn't see that, not a big deal. Okay, number 10. It says find the area of the shaded region. Well, if I find the area of the whole thing, and then I take out the white part, that leaves you with just the shaded. So what I'm going to do is find the total area of the box. So the total, remember, area is equal to length times width. So the length and the width of this box is x plus 2 and 3x. So the total area is 3x times x plus 2, which if we distribute the 3x, that gives us 3x squared plus 6x. Now we're going to find the area of this white part in the middle, because that's the part we don't want. Again, its area is length times width. So this is x times 2x, which gives us 2x squared. So this is, you can kind of think about this as being a huge pizza. So the pizza, we start off with 3x squared plus 6x, and then someone cuts out the middle and eats it. So we want to figure out how much pizza is left over. So we take what we started with, which was 3x squared plus 6x, and then we subtract the part we took out. And we took out this 2x squared. And now we look for like terms. And see, I've got a 3x squared and a minus 2x squared. So that gives me 1x squared, which we just write x squared. You can put the 1 in front if you want to, plus 6x. And that's our final answer. That is the leftover part. So you'll see on number 11, it's the exact same thing, just with different dimensions. We want to find the area of the shaded region, which means we got to find the area of the whole thing, and then take out this piece. So we'll do that again. I'll put it over here. So we're going to find the total area first, which is x plus 5 times x plus 5. But if we notice, this is just like that question we did a few minutes ago when you multiply a binomial times itself. So I'm going to take the shortcut here again. So I'm going to square the x's, so that's x squared. I'm going to square the 5's, which gives me a plus 25. And then the middle is going to be 5 times x doubled. So 5 times x is 5x. If we double it, that's 10x. Then the white area, same thing. We're going to do an x minus 2 times an x minus 2. Or we could write that as x minus 2 squared. So we're going to use the same shortcut. Square the first term, square the last term, and then the middle is these multiplied. So negative 2 and x make a negative 2x. Now double that. Negative 2 doubled is negative 4. So now, to find what we want, we started off with the entire pizza, which was x squared plus 10x plus 25, and we're going to take out the part that was the white. Someone cut that out and took it away. Now this time, since I'm subtracting more than just one number, I'm going to put it in parentheses, and you're going to see why in just a second. So I'm subtracting this entire expression. So let's get rid of those. I know I just put the parentheses there, but now let's get rid of them. And you're going to see why I put the parentheses there in order to get rid of them, because it seems counterintuitive, but it helps. So if we get rid of those parentheses, since we're subtracting, they all turn to their opposites, because we're multiplying by a negative. So we have a negative x squared, a positive 4x, and a negative 4. Now we can combine like terms. X squared, negative x squared, they cancel out. 10x, 4x, so that makes a 14x. If we didn't put the parentheses around it, some of us might have thought that that was a minus 4x. But because we were subtracting a negative 4, it really turned into a plus 4. And that's why the parentheses are helpful. And then we've got a 25 and a minus 4, which makes a positive 21. So 14x plus 21 is your area. All right, now on to our factoring. So when you factor, remember, we've got that list of what we should always check for. And so I'm going to keep that list off to the side over here. first thing we always look for is a GCF. The next thing we look for after GCFs are the diamonds. Then we look for the box diamond. And then finally we look for the difference of squares. And technically there's that factor by grouping that happens every once in a while. But we're going to talk about that when we see it, because we know when we always use it is whenever we see 4 terms. So let me focus back in on this. So here we go. We're going to run through the process. So number 12, first thing we look for is a GCF. So I see a 10 and a 15, and yes, they have a factor in common. 5 will go into both of them. So we're going to pull out a 5. Then we look at their variables. They both have x's, so we got to pull out the most that they have in common. This has 2 and this has 1x. So they only have 1x in common. So that's all I'm allowed to pull out. So that's your GCF, which is the 5x. So now to get the insides, you divide by what you pulled out. So 10x squared divided by 5x. So 10 divided by 5 is 2. X squared divided by x is just x. 15 divided by 5 is 3. X divided by x, they cancel out, so you're done. How do you know if you've done it right? Well, if you distribute this back in, you should get your exact same equation, which we do. So we've got the GCF. Now I look at what's left over and see if I can use a diamond, which I can't. Can I do a box diamond? Nope. Do I have difference of squares? No. So I've gone through the whole process of looking for GCF, diamond, box diamond, difference of squares. All right, on to 13. First thing we look for is GCF. Have one. 18 and 30. Biggest thing I'll go into 18 and a 30 is a 6. Then I look at variables. This has 7 x's, this has 3 x's. So the most that they have in common is 3 x's. So I pull it out. Then I go to the y's. This has 3 y's, this has 1 y, so I pull out 1 because that's the most they have in common. So now, to get the insides, again we do division. 18 divided by 6 is 3. X to the 7th divided by x third. Remember when you're dividing with exponents, or dividing with variables and they have exponents, you subtract them. So 7 take away 3 is 4. 3 take away 1y gives you 2y, so y squared. Negative 30 divided by 6 is negative 5. X third cancel. Y divided by y cancel. So that's your insides. So we did the GCF. Now we look for a diamond. Not set up for the diamond. Not set up for a box diamond. And this is not difference of squares. So we've gone through the whole checklist. All right, number 14. First step, look for GCF. Nothing, no variables in common, nor any factors in common other than 1. But everyone has 1 in common, so we never pull that out. So there's no GCF. Check for a diamond. Yes, it's set up like a diamond, because we have a y squared, a y, and a constant. So again, for the diamond, if you use the diamond, you're looking for 2 numbers that add to give you a 7 and multiply to give you a 6, which some of you have just been writing it this way, which is fine. Others of you like to put in that graphic organizer. So your add number goes on the bottom, your multiply number goes on the top. So we're looking for 2 numbers that make that work, which in this case would be a 6 and a 1. So we have y plus 6 times y plus 1. 6 plus 1 gives you 7. 6 times 1 gives you 6. So then that's our answer. To check it, you could do the multiplication through and see if it gives you this answer, which in this case it does. All right, on to the next page. And technically, well, I forget, just because I know what the answer is to this one. After we do the diamond factoring, I would look to see if there's anything else we can do, which there isn't. We did diamond. It's not set up for box diamond when you're done, nor do you have difference of squares. So we still go through the checklist, so I want to make sure we still keep looking for that. All right. Again, I'm going to make my checklist up here. We go GCF, diamond, box diamond, and difference of squares. So here we go. GCF doesn't have one. Diamond. It's set up for a diamond, so we got to see if it works. So we're looking for two numbers that add to give me 8, multiply to give me negative 48. So for my diamond people, our add number goes on the bottom, multiply number goes on the top. First thing I'm going to do is figure out the signs. If I'm adding to get a positive and I'm multiplying to get a negative, that means the two symbols have to be opposites of each other. We have to use one positive and we have to use one negative, because that's the only way to multiply to get a negative. So I'm going to put a plus and a minus. Then I start thinking, okay, well, if you're adding a positive and negative together, you're really going to find the difference between those numbers. So now my mind switches a little bit, saying, okay, what multiplies to 48? But if I subtracted, would give me an 8. So I just start making a list. Now I know what the numbers are right away, but for those of you who have difficulty, you can just start with the number 1. So 1 and 48. That doesn't work, because if you subtracted them, you would not get an 8. So then go to the number 2. 2 goes into 48 24 times. 2 and 24, the difference is not 8. So we move on to 3. 3 goes into this one 16 times. So we're getting closer, because the difference between those is 13, so we're still not at 8 yet. So now we'll go to 4. 4 and 12. Yes, the difference between a 4 and a 12 is 8. I'm going to make the 12 positive, because I need to have more positives than negatives. So 12 plus a negative 4 is a positive 8. So we've got our answers, a plus 12 and a minus 4. So we did the diamond. I look at my leftovers. Neither of these are box diamonds, and we don't have difference of squares. So that one is done. On to number 16. So GCF, don't see one. So we put an X for the GCF part. Then we look for a diamond. It is set up for a diamond. So we're going to add to get negative 12, multiply to get a 48. So add negative 12, multiply 48. So I see that I multiply to get a positive, but add to get a negative. So that means it's got to be two negative numbers. And again, you would go through this whole checklist of numbers, but since we look at it, we could keep going. I could look at these because these were the exact same, multiply to get 48. Well, none of these numbers so far, when I add them, give me a 12. So I could keep looking. So the next thing that goes into 48 would have been a 6. So it would have been 6 times 8. Well, 6 and 8, when we add them, gives me a 14. And then after that, there's nothing else that goes into 48 other than these numbers. And since none of these numbers add to give me a 12, we can't factor. And when you can't factor, we write prime. So this one you cannot go, you can't factor. So there's no need to, I'll put X's here though, because none of this works. All right, number 17. Look for GCF again. Don't have one. Nothing goes into 2, 5, or 3. They have no common variables, so GCF is out. Diamond, not a diamond because of this 2 in the front. These didn't look like these where there's 1s in front. So that means we're going to the box diamond. Box diamond is when you have that number, your leading coefficient is not a 1. And here's how the box diamond works. So we get the focus. We're going to fill out the box. Normally we know the outside parts to get the inside parts. Well, this time we're going to fill in the inside parts. So if you noticed, anytime you did your multiplication, the x squareds always ended up in the top left. So that's where we're going to start. So our 2x squared goes in the upper left. Also, when you did your multiplication, your constant always ended in the bottom right. So that's going to end up here. So we've got 2 boxes left over and a middle term we haven't used yet. Well, that means that 5x is going to be split between these two. Well, there's a lot of different ways to split a 5. You could do a 4x and a 1x, a 2x and a 3x. You could even use negatives. So we got to figure out the right combo. How do we do this? We go back to the diamond. But this time, our multiplication number is different. It's no longer going to be a 3 because this 2 has messed everything up. So since it messed everything up, we make it do a job. Its job is to come over here and multiply that 3. So if we multiply 2 and 3 together, that gives us 6. So that is our new multiplication number. Our new multiplication number is 6. Our add number is still going to stay the same, of 5. So we figure out two numbers, add 5, multiply 6, that's an easy one. It's a 3 and a 2. These are what go in to these. So this 3 and this 2 are your x's. That's what makes your 5x. And it doesn't matter where you put them. If you decide to put the 2x on the bottom left and the 3x in the upper right, you'll still get the same answer. Now comes the last step. We're going to pull out the GCF of each column and each row. So of this column, the GCF is an x. Of this column, the GCF is a 1. Of this row, we have a 2x. And of this row, we have a 3. And we have our answer. X plus 1 times 2x plus 3. Box diamond is done. I still go back and look. There's no difference of squares for this. So I've checked off all list on here. Number 18. Now, number 18, this right away, I see something. This is different. We have 1, 2, 3, 4 terms. Whenever you see 4 terms, the first thing you're going to look for, this is the one and only time you don't really follow these steps, you go straight to what's called factor by grouping. And to do factor by grouping, we're going to split our problem right down the middle. And we're going to do two separate problems. The nice thing with factor by grouping is you're just doing greatest common factors on two separate problems. So we're going to GCF these first two terms. So 3 and 12, pull out a 3. X cubed, x squared, the most they have in common is an x squared. To get our insides, we do division. So 3 divided by 3 is 1, so I'm not going to put that there. X cubed over x squared gives you an x. Negative 12 divided by 3 is negative 4. X squared over x squared, they're gone. Now in order for factor by grouping to work, remember this set of parentheses has to show up over here. So I'm automatically going to put it there and see if it's possible to do that. So I got to figure out, can I multiply an x minus 4 by a number to get a 2x and a minus 8? Which we can. If I multiply by 2, I get the 2x. 2 and negative 4 give me the negative 8. So it does work. So then your answer, your x minus 4 is going to be one set of parentheses. Your other set is what the x minus 4 was multiplied by. It was multiplied by 3x squared, and it was multiplied by a positive 2. So that's where we put our plus 2 in. Then I look. There's nothing left. There's no difference of squares here. There's no diamonds left. So I'm done with the process. So now we go to 19. First step we look for is our GCF, which I have. So GCF, checking off, we're going to do it. So 8 and 200, the biggest thing that will go into both of those would be a, I believe it would be a 4. It's going to be the biggest thing that goes into both. Actually, I think an 8 will go into both. Yes, an 8 does. Obviously, 8 goes into 8, but 200 I had to think about. So yes, 8 goes into 225 times. So we're going to pull out an 8. So we pull out the 8. Then to get the insides, we divide each thing by 8. So 8 divided by 8 is 1, so you're left with that x squared. 200 divided by 8 is 25. So GCF is done. I look. Do I have a diamond? Nope. So no diamond. Is it a box diamond? Nope. No box diamond. Difference of squares? Yes, we do have difference of squares. Because this is subtraction, just thus the word difference. Squares meaning you can take the square roots and you get whole numbers, which we do, or whole variables. So this becomes 8. Square root of x squared is x. So when you do difference of squares, you take the square roots. That's your first terms. Then you take the square root of the second term. Square root of 25 is 5. You make one a plus and one a minus. So difference of squares, check, and that's the last thing we look for. On to number 20. First thing we look for is that GCF, which we do have. They all have an x in common, so we pull it out. So x squared minus 7x plus 12. But we got to look and see, do we have a diamond set up for us? Yes, we do. X squared, x 12. So we're looking for two numbers that add to give us negative 7, but multiply to give us a 12. Those of you that do the diamond, add negative 7, multiply 12. We see that when I add, I get a negative, multiply, I get a positive. That means I have to have two negative signs. So we go through the whole process. 1 and 12 wouldn't work, 2 and 6 wouldn't work, 4 and 3 do, because negative 4 plus negative 3 is your negative 7. So that's your new parts, x minus 4 and x minus 3. And some people will circle that as their answer, but what you can't forget, you pulled that x out at the beginning, so you have to give that x credit for the problem. So that x has to go in front of your expression. So x times x minus 4 times x minus 3. Diamond is done. Box diamond, don't have anything. Do we have difference of squares? No. So we've checked off all pieces. Okay, 21. Here we go again. Looking for a GCF. Don't see one. Look for diamond. Not set up for one. Look for box diamond. Isn't. Difference of squares. I see difference. Are these two things we can take the square roots of? Yes, they are. So that's what we're going to do. So the square root of 16 is 4. Square root of h squared is h. Then we go square root of 81, which is 9. Square root of y to the 4th is y to the 2nd. We make one a plus, one a minus. Then we look, do we have anything else left over? Do we have any more difference of squares? We do not, so we are done. 22, GCF, don't have one. Diamond, not set up. Box diamond, not set up. Difference of squares. And some people go, yes. Some people want to do 2x plus 3 times 2x minus 3. If you did this, make a note to yourself. That's wrong. Because, and circle this, that's a plus sign. Our rule is called the difference of squares. Difference means subtraction. This is not a subtraction sign, so therefore we can't use difference of squares, which means we didn't find any factoring that we could use on this problem. So our answer is prime. All right, we're getting closer to being done. So number 23 now. Let's see, 23. The first thing I see is that I've got 4 terms. So what do? We're going to split that down the middle to do factor by grouping. So 25 and 30, we find the GCF. It's going to be a 5. H cubed, h squared, I can pull out an h squared. Do our division to get the inside, so that's going to be a 5 and an h, and that's going to be a 6. In order for factor by grouping to work, I have to get a 5h plus 6 over here. If I can't figure out how to get a 5h plus 6 here, I can't do it. So can we multiply 5h by something to get a negative 30h? Sure, a negative 6. Does negative 6 times 6 give me negative 36? It does, so that means factor by grouping works. So again, our answer, 5h plus 6. What else did we multiply the 5h plus 6 by? A 5h squared and a minus 6. So they go together in the same group, and we have our answer. Can we do difference of squares here? No, because these are not perfect squares. 24 is the area of a rectangular coffee table is given by this. I'm going to draw this out. So we got a coffee table, and it says the area is t squared plus 7t minus 8. It says the length is t plus 8. They want us to find the table's width. Well, what we have to realize is that when you find area, it's length times width. We don't know the width. So we're trying to figure out what do you multiply t plus 8 by to get t squared plus 7t minus 8. Well, whenever we're trying to find missing multiples, that's really just called factoring. So all we have to do is factor this problem. So this is a diamond. We're looking for something that adds to give me 7, multiplies to give me a negative 8. So I know I have to use one negative and one positive. So the first thing that comes to mind is 8 and 1, which would work out perfectly. If I used a positive 8 and a negative 1, which they had the plus 8 there for us, so that was kind of a cheat right there. So it has to be t minus 1 times t plus 8. So our missing dimension was t minus 1. Okay, 25, probably one of the more difficult ones on the study guide. Let's draw this out. Window is 2 feet by 4 feet, okay? 2 feet, 4 feet. Once it focuses. And it says a clear glass border is constructed around the stained glass window. Okay, so we've got a border around this window. And it says the width of the border is unknown. Other than the fact we do know one thing about it, it's equal. The width of the border is equal all the way around it. So we don't know what it is, but we know it's equal. So that means the width. So from, just draw a squiggly right there, from the window to the edge, from the stained glass to the edge of our border, we're going to make that x. It's unknown. Well, since they're all the same, the width is all the same on all of them, this is going to be x. This is x. And this is x. And it says that 7 square feet of clear glass is what this border is made up of. So what I could do, because we got to find this x, we could make some equations here. Kind of like what we did a little bit earlier. We could figure out the total area. The total area, we need the overall length and width. So to get from here to the top, I have to go up x, up another 2, and up another x. So x plus 2 plus x, that gives me 2x plus 2. Well, then I got to find out how long it is all the way across. Same process. To get from here to here was an x. To travel along this line is worth 4. And from here to here is x. So x plus 4 plus x is 2x plus 4. So now we multiply them together to get the total area. So 2x plus 2 times 2x plus 4. This time, because I'm running out of room, I'm not going to use the box method. I'm just going to do distributive property. 2x and 2x make 4x squared. 2x and 4 make 8x. Excuse me. 2 and 2x make 4x. 2 and 4 make 8. Combine like terms. So 4x squared plus 12x plus 8. That's our total area. Again, we can't do anything to solve for x unless we know what the total area actually equals. Well, we do. We know what the total area is, the window plus the border. Well, the window, we can find the area of this window. The window's area is 4 times 2, which equals 8. Then you might be saying, well, how do I find the area of our border? We don't have to find it because they tell us. They say it took 7 square feet of clear glass to make the border. So the border is worth 7. So that means the total is 8 plus 7. The window plus the border gives us all the material, which is 15. So this equation has to be equal to 15. Well, now how do we solve for something like that? Well, remember, when you're solving for x squareds and x's, your equation has to equal 0. So at this point, I'm going to go to a new sheet to write this down. So I'm going to subtract 15 to make this equal to 0. And if I do that, I'm going to get 4x squared plus 12x, right? Yeah, 12x. And then 8 take away 15 gives you a negative 7. So at this point, you've got options. You could use the quadratic formula, or you could try to factor it. And to factor it, it would be a box diamond, and we'd have to find two numbers that add to give us 12 and multiply to give us negative 28. So you need a negative and a positive, And then we just start thinking what multiplies to give us 28. 1 and 28, that wouldn't work. A 2 and a 14, that's going to be perfect. Because I'll make the 14 my positive, my 2 my negative. Because when we add, we get to 12. So since I know that I can find numbers, now I'll go make my box. Again, to do that box, your x squareds are always in the upper left. Your constant is always in the bottom right. And your two numbers from the diamond that you came up with make your missing boxes. So negative 2x, 14x. So now we find the GCFs. 4x squared, 2x. We can pull out a 2x. 14x, negative 7. I can pull out a 7. 4x squared, 14x. I can pull out a 2x. Negative 2, negative 7. I can pull out a 1. And it's a negative 1 because I'm touching a negative box. This was a positive 7 because I was touching a positive box. So now we've got an equation. 2x plus 7 times 2x minus 1 is equal to 0. Well, if you multiply two things together and your answer is 0, that means one of them had to have been a 0. It's the only way to get an answer of 0 is if you multiply with a 0. So either this person was our 0, so 2x plus 7 could have been the 0, or 2x minus 1 could have been the 0. So let's solve. Subtract 7, divide by 2. We get negative 7/2 for this equation. For this one, we would add 1, divide by 2. We would get 1/2 for this one. So here's our answers. And if it was just a theoretical question and this was it, you would circle both. But because this is talking about a real border, real glass, you can't have a width of negative 7/2. It doesn't make sense. So therefore, our width has to be 1/2. And for our last one, describe and correct the error made in simplifying the product below. Again, the error is what a lot of students do. That's why I put this one on here, is they just square the first and square the last, and they think that's the answer. But when you square a binomial, you can't forget about that middle term. And these are the ones we did earlier in the study guide. So we square the first, which that was fine, the 4x squared. Square the last, so negative 3y squared does give you a 9y squared, so that part was perfect. But now we get the middle. To get the middle, you multiply 2x and negative 3y, which gives you negative 6xy. Then you, don't forget, double, which gives you a negative 12xy. And that's our final answer. Or for those of you that still don't like that shortcut, you can do 2x minus 3y times 2x minus 3y and do the distributive property, or use your box method. And that's it for this one.